Hello. Welcome to the stream, everyone. This is your hacker Cyan. Hello. Welcome, Nerdy Afro. Welcome, Zoe. Welcome, Maxim. Welcome, Enden. Welcome, Dragon1320. Welcome, Warrior-san. Welcome, Lloyd. Welcome, Batomi. Welcome. How do I call you? Cute eyes. Welcome, Sergey. Hello. Welcome, Mixisuke. Welcome, Adam. Welcome, Capri. Oh my god, so many people. Welcome. Is this the second to last stream of Rust? We are on chapter 19 of advanced features, and the next chapter is gonna be the final project. 比妈好，早点睡觉，安安。So we are pretty close in finishing the book, and today we're talking about some of the advanced features, including advanced types, advanced function enclosures, and macros. Welcome, Gato. I'm far from certified Rust expert. I feel like this book deserves to be read like multiple times. We're gonna start this all over again. No, just kidding. Just kidding. Today, let's look at the advanced features of Rust. And I don't know what am I gonna do after finishing reading them. I just wanna understand as much as possible before my head explodes. Yeah, it's pretty much the beginner book. Welcome, Alias. Yep. So let's get started. What are advanced types? The Rust type system has some features that we have mentioned in this book but haven't yet discussed. We'll start by discussing new types in general. We're learning new types. As we examine why new types are useful as types, then we'll move on to type aliases, a feature similar to new types but with slightly different semantics. We'll also discuss the exclamation type. Is it the never type? And dynamically sized types. So we're talking about different types. Advanced, scary. It's better than Rastomonian. It's not too advanced, I guess. It's called. Let's see how advanced they are. Reborn and automatic reborn. Oh gosh, it's all hard. The whole borrow thing of Rust is so unique. Welcome, Ayumi. Hello. Welcome, Beckomania. Yup. So what is the new type pattern? It's for type safety and abstraction. The new type pattern is useful for tasks beyond those we have discussed so far, including statically enforcing the values, statically enforcing that values are never confused, and indicating the units of a value. You saw an example of using new types to indicate units before. If we wrote a function with a parameter of type millimeters, we couldn't compile a program that accidentally tried to call that function with a value of type meters or plain integer, unsigned integer. Another use of new type pattern is in abstracting away some implementation detail of a type. The new type can expose a public API that's different from the API of the private inner type if we use the new type directly to restrict available functionality, for example. It's abstracting away some implementation details of a type. It feels like the not the polymorphism, the object-oriented. It exposes public API and hide the private API. New types can hide internal implementations. For example, we could provide a people type to wrap a hashmap integer string that stores a person's ID associated with their name. Code using people would interact with the public API we provide, such as a method to add name string to the people collection. That code wouldn't need to know what we assign an integer ID to names internally. The new type pairing is a lightweight way to achieve encapsulation to hide implementation details, which we have discussed in the object-oriented chapter before. So what is this talking about? It's saying we can use a people type to wrap a data structure, and we would provide a public API to add a name to the people collection, and it wouldn't know that we assign an ID to it. So we hide the ID assignment in the code, in the new type, instead of using a hash map. Direct. Okay, creating type synonyms with type aliases. Along with the new type pattern, Rust provides the ability to declare type alias to give an existing type another name. For this, we use the type keyword. For example, we can create alias kilometers to I32, like so. Something like that. So basically, kilometers is a synonym for integers. It is not a new type. So basically we call the type a different name. So if we try the example, type kilometers. Oh, it is uppercase equals to the integer at x equals to 5, and the type is integer, and y, the type is kilometers, equals to 5. And since it's synonym, they are the same type. So it's okay if we add them together. So if we run this, even though one type, the naming is kilometer, is still integer, so we can still add them together. It looks like the syntax from C++. I'm hoping that we won't need to use C++ anymore. We can just use Rust to replace C++. It's 34 of begging Cyan to show her extra jiggle wiggle content. What? I don't have extra jiggle wiggle content. Your brain is jiggle wiggle too much. Too much. Welcome, Rafaten, and thank you, Arya-san. Yup. So, oh, if we use this method, we don't get the type checking. So that's something to know about. And the main use for the type synonyms is to reduce repetition. So basically, we have this giant type. We don't wanna type. We can give it a name. So we don't have to write complicated code like those. We can just give a name of sunk to this extra complicated type. And when we declare the types, we don't need this big chunk of code. We just need to have the name of it. Studio Ghibli members only watch alone. Oh my god. Ghibli Wibbly content is possible. Thank you, Tsue. Yep, so basically it's giving a name to your long type. That is the use of type synonyms. Welcome Mario, hello! How's your night going? It's so late, people. Don't sleep late. Type aliases are also commonly used with result type for reducing repetition. How? Consider the standard I/O module in the standard library. I/O operations often return a result to handle situations when operations fail to work. This library has a standard I/O arrow struct that represents all possible I/O arrows. Many of the functions in the standard I/O will be returning result, where E is the arrow, such as this function in the right trait. So the functions returns result, and it's repeated a lot. So we declare a type aliases. The right trait function signature end up looking like this. Oh, it's much more cleaner. If I compare them side by side, it's probably gonna show better. Or are they the same? The alias is here, so it omit the arrows. We don't need to mention those arrows while it's still in there. So slightly less code. And we're going to talk about the never types. The never type. What is the never type? Rust has a special type named exclamation mark that is known in type theory lingo as the empty type because it has no values. We prefer to call it the never type because it stands in place of the return type when a function will never return. Here is an example. So the function bar returns never. So the function never returns. It's a diverging functions. We can create values of the type never type, so the bar can never possibly return. But what use is a type you can never create values for? Recall the code from here. We have reproduced part of it here. So this is the guessing game we have returned. And right here, we have a match expression. We have a match expression that returns either a OK. A match expression if it has a OK of num, it returns the num. If it has nothing, then if it has an arrow, then continue. And the match arms must return all the same type. So what does continue return? So this match is trying to return an integer or a continue. But what the heck is a continue? Well, continue has a narrow type value. When Ross computes the type of guess, it looks at both match arms, the former with a value of integer and later with a narrow type value. Because the narrow type can never have a value, Ross decides that it's the type of guess is unsigned integer. Oh, so because this continue never have a value, the type is narrow type. So the guess is only gonna be unsigned integer. The narrow type is about computation that never come back to the caller. Is void is similar to the narrow type. I think yes. The formal way of describing this behavior is that the type narrow type can be coerced into any other type. We are allowed to end this match on with continue because continue doesn't return a value. Instead, it moves control back to the top of the loop. So in the arrow case, we never assign a value to guess. The narrow type is useful with the panic macro as well. Remember the unwrap function that we call on option T values to produce a value or panic. Here is the definition. The definition. So this is the unwrap function implemented for option. And in the panic, the rod sees that the value has the type T, and the panic has the type no type, narrow type. So the result of the overall match expression is T. This works because panic doesn't produce a value, it ends the program. In the none case, we won't be returning a value from unwrap, so the code is valid. So it's quite similar to last example. If one arm has no value returned, then the return value of match is gonna be the type of the value. Welcome team, hello. Long time no see. Welcome. One final expression that has the type narrow type is loop. Loop never ends, so narrow type is the return value of the expression. However, this wouldn't be true if we included a break, because the loop would terminate when you go to the break. The narrow type is like bottom type. I honestly feel there are so many similarities between Rust and Haskell in the functional languages features. The bottom actually has a symbol. It kind of looks like a butt. I've never used it. Haskell is cool. The bottom refers to a computation which never completes successfully. There's a mathematical symbol for the bottom. That's so interesting. Okay, moving on. Dynamically sized type and the size trait. Due to Ross needs to know certain details, such as how much space to allocate for a value of a particular type, there is the corner of his type system that can be confusing. The concept of dynamically sized types, sometimes referred to DST or unsized types. These types let us write code using values whose size we can know only at runtime. Let's dig into the details of a dynamically sized type called stir, which we have been using throughout the book. That is right, not string slice, but stir on its own. It is a dynamically sized type. We can't know how long the string is until runtime, meaning we can't create a variable of type stir, nor can we take an argument of type stir. So if we try to declare something of type stir at s1 equals to height, this wouldn't work. Because the size of stir cannot be known at the compilation time. Rust steals almost its type system from Haskell and languages like it. That's why there are so many similar concepts. Haskell has a bottom type. Yeah, search it. Hello, Adam! Welcome. You're writing C, that's awesome. That's so cool. I don't feel I can ever understand how to write good C code. I'm scared of pointers and unsafe pointers. Konnichiwa, welcome, Luca. Rust needs to know how much memory to allocate for any value of a particular type, and all values of a type must use the same amount of memory. If Rust allowed us to write this code, these two stir values would need to take up the same amount of space, but they have different lengths. This is why it's not possible to create a variable holding a dynamically sized type. So the reason we cannot create a variable holding a dynamically sized type is because even though those two variables has the same type, they apparently has different size. They need different amount of storage. So what do we do? In this case, you already know the answer. We make the types of S1 and S2 a string slice rather than a string. So make it into a string slice. And boom, everything just works. It stores the memory address where the stir is located. It has the address of the stir and its length. So we can know the size of a string slice at the compile time. It is twice the length of a usize. We always know the size of a string slice no matter how long the string it refers to it. In general, this is the way in which dynamically sized types are used in Rust. They have an extra bit of metadata that stores the size of dynamic information. The golden rule of dynamically sized types is that we must always put the values of dynamic size type behind the pointer of some kind. So the string slice has the location of the stir, and it has the size of the stir, and it's the twice length of the U slice. Nice. How are we liking Rust so far? Pretty good. It's pretty fun to learn about. We can combine stir with all kinds of pointer. For example, a box smart pointer or a reference count pointer. In fact, you have seen this before, but with a different dynamically sized type, traits. Every trait is a dynamically sized type we can refer to by using the name of the trait. So trait is a dynamically sized type. To use trait as trait objects, we must put them behind the pointer. To work with dynamic size types, Rust has a particular trait called the size trait to determine whether or not a type's size is known as compile time. This trait is automatically implemented for every scene whose size is known as compile time. In addition, Rust implicitly adds a bound on size to every generic function. That is, a generic function definition like this is treated as though it's being written like this. There's a sized. By default, generic functions will only work on types that have a non-size at compile time. However, you can use the following special syntax to relax this restriction. It adds a question mark. A trait bound on question mark size means it may or may not be sized, and this notation overrides the default that the generic types must have a non-size at compile time. The trait syntax with this meaning is only available for size, not for any other trait. It's only available for size, so this is like very special. Very special. Also note that we switch the type of t parameter from t to the reference of t because the type might not be sized. We need to use it behind some kind of pointer. In this case, we have chosen a reference. Okay, so that's all the content about advanced types. We learned about new types, new type pattern, for some encapsulation and abstraction. We learned about type synonyms, type synonyms for creating new names for existing type to make the code shorter, and we learn about the never type, which never returns, basically void, and dynamically sized types that automatically has the sized trait. Type cinnamon. I was like, I think cinnamon is a word. Cinnamon is something I originally hated, but eventually I kind of like it. The cinnamon sugar, cinnamon rolls. It's just a tongue twister for me. I don't know why. Okay, advanced functions and closures. Advanced functions and closures. What are some advanced functions? Which includes function pointers and returning closures. Oh, so we are going to learn about function pointers and how to return closures. And this is also super like Haskell because we get to return functions. Honestly, the first time I heard it, I was pretty shocked. Didn't know we can just return a function. Function pointers. We've talked about how to pass closures to functions. You can also pass regular functions to functions. This technique is useful when you want to pass a function you already defined rather than defining a new closure. Doing this with function pointers will allow you to use functions as arguments to other functions. Function coerce to the type. Functions not to be confused with function closure trait. The function type is called a function pointer. Oh, so this is a function pointer. The syntax for specifying that a parameter is a function pointer is similar to that of closures. Oh my god! Thank you for the donation. Nice super. Thank you. Thank you, Warrior-san. I was shocked. I forgot donation is a thing. Thank you so much. Thank you, Aliases. Are we doing functional programming now? Yes. I think so. This is a function programming. You return a function. So we have a function of add1, takes an integer and returns an integer, and it adds 1. It returns. Wait, what? Oh, it does return an integer. Nice and easy. And then we have a function do twice that takes the function, the freaking function. It's a function that returns an integer and it also returns an integer. The do twice also return the integer. Oh, it takes a function and the argument and call the function using the argument twice and return the integer. So in the main function, that answer equals to do twice at 1, 5, and we print line the answer answer. Sorry for interacting me. No, thank you for the super chat. Oh, so it calls the function twice on the argument 5. So it's 6 plus 6 and returns 12. Unlike closures, function is a type rather than a trait. So we specify the fn as the parameter type directly rather than declaring a generic type parameter with one of the function trait as a trait bound. Function pointers implement all 3 of the closure traits: function, funcmute, func_once. So you can always pass a function pointer as an argument for a function that expects a closure. It is best to write functions using a generic type and one of the closure traits, so your function can accept either functions or closures. Write function using a generic type and one of the closure traits. So because function pointers can be passed in a function, that expects a closure, so we should use generic type. to write the function. So the function can accept either functions or closures. An example of where you would want to only accept a function and not closures is when interfacing with external code that doesn't have closures. C functions can accept functions as argument, but C doesn't have closures. Oh, but this is an example you don't want to accept closures, because C doesn't have closures. And that as an example of where you could use either a closure-defined inline or a named function. Let's look at a use of map. To use the map function to turn a vector of numbers into vector of strings, we could use a closure. So what do we have here? I am a work companion? I am a work companion? I wish somebody hire me. I'll be a professional work companion. List, we have list of numbers, which is a vector of integers. And we're converting it to a list of string. And we use a closure to map to each of the elements in the vector. Selector. Can I do this? This is going to turn them into strings. Yes, those are tattoos. Oh, so we have used closures to turn the numbers into strings. Now, we can use a toString function. We could name a function as the argument to map instead of the closure. So instead of this big boy of closure, we use the toString function. We map the toString function, and it perfectly converts all the integers to string. $200 horse head emoji? What are those? Welcome, Evan. I got in prison. That's possible. People might want to arrest me for being using an unsafe Rust. It's a crime. It's a crime for the Rust compiler if I don't use the unsafe keyword. I guess you ain't getting a job in the service industry or onset. Yeah, but I really want to go to the hot spring. Welcome, Mohammed. Long time no see. Yes, I miss seeing you people at this time. So, yeah, I'm streaming. I think both of my stream this week is on this time. Perfect time to finish Rust. Yay! Now that we must use the fully qualified syntax that we talked about earlier in advanced traits section, because there are multiple functions available named toString. Here we are using the toString function in the toString trait. So that's the column, which the sender library has implemented for any type that implements display. Thank you, Lawyer-san. You're so nice. Okay. We have another useful pattern that exploits an implementation detail of tuple structs and tuple struct enum variant. Oh, tuple structs. This type uses parentheses as initializer syntax, which looks like a function call. The initializers are actually implemented as functions returning an instance that's constructed from their arguments. We can use this initializer function as function pointers that implement the closure traits, which means we can specify the initializer function as arguments for the function that takes closure. So we have an enum of status value stop. That list of statuses vector status. Oh, what is that? Equals to from 0 to 20, we map it to status value dot collect. What have I written? So we have a vector of status. And we map those numbers into status. And we collect them. So we got a bunch of values with numbers. We create status value instances using each integer value in the range that map is called by only using the initializer function of status value. Oh, so this is the initializer function. Here are my numbers, and I throw the initializer function on them, and then they just become instances of value. Welcome, Havnia, 欢迎。Macros are one of the less polished parts of Rust, but still nice to have. We're moving on to macros almost. Fully qualified syntax. Fully qualified syntax. Oh. Yes. It tells very clearly which function, which method are you calling to. What do I plan to do with Rust after finishing this book? I wanna write some programs. I don't know if I'll do it on stream. I just thought Rust is a fun skill set to have and may come to use one day. Macros are one of the less polished parts of Rust, but still nice to have. What? It will be fixed in a few months? I wanna see what will go on. I will write an AI streamer bot with just Rust. Dang. I'll have some AI to stream for me. A truly AI VTuber. We're not talking about having a person behind. We're talking about an AI VTuber. Oh my god. It should also have some programs to, use the AI to play the games like Flappy Bird. It streams all the perfect runs. And automatically replies to the chat. That's gonna be so cool. I wonder if you can legally marry an AI VTuber. Ask society, I have no idea. Oh my god. Well, oh my god. The first truly virtual VTuber. That would be so cool. Okay. Closures. We're going to return closures. Closures are represented by traits, which means you can return closures directly. In most cases, where you might want to return a trait, you can instead use the concrete type that implements the trait as the return value of the function. Oh, so we can return closures directly. But you can't do that with closures because they don't have concrete type that's returnable. You are not allowed to use the function pointer as a return type. So it's saying we can return closure, though. How do we do it? Oh, you just poke a box around it. I feel like all the problems in Rust, you just put a box around it and it just works. The problem with that function is the return type cannot be an unboxed trait object. The Rust doesn't know how much space it will need to store the closure. So we can use a trait object. Boom. That's so nice and short. This works. Cyan Eve. Man, this is getting real. It's getting real. Okay, moving on to macros. Macaroni. We have used macros like print lines throughout the book, but we have not fully explored what a macro is and how it works. The term macro refers to a family of features in Rust. Declarative macros with macro rules and 3 kinds of procedural macros. Cyan Eve Macaroni. Will you have a last name? Macaroni? I don't know if that's a good name. Good last name. Mrs. Macaroni. So delicious. Okay. What did I just read? What did I just read? Oh, we have different types of macros. Declarative and procedural. And procedural macros include custom derived macro that specify code added with the derived attribute used on structs and enum. Attribute-like macro that define custom attributes usable on any item. Function-like macros that look like function calls but operate on tokens specified as their arguments. So we have derived macros, attribute-like macro, and function-like macro. And let's talk about why do we need macro. The difference between macros and functions. The macros are a way of writing code that writes other code, which is known as metaprogramming. We discussed the derived attribute, which generates an implementation of various traits for you. We've also used the printline and whack macros throughout the book. All these macros expand to produce more code than the code you have written manually. Metaprogramming is useful for reducing the amount of code you have to write and maintain, which is also one of the roles of functions. However, macros have some additional powers that functions don't. A function signature must declare the number and type of parameter the function has. Macros, on the other hand, can take a variable number of parameters. Oh, so function is limited on the number and type of the parameters, because you need to declare how many numbers and what type of parameter I need to accept. But macros, you can call it with one argument or two arguments. And macros are expanded before the compiler interprets the meaning of the code. So the macro can, for example, implement a trait on given type. A function can't because it gets code at runtime and the trait needs to be implemented at compile time. They're hacky. I wanna see their hacky side. Proteins, fats, and carbs? What are those macaronis? We're not in biology class. Hey, this is not a biology class. So the difference between macro and function is function has to take specific types and numbers of variable, while macro doesn't need to. And macros can implement a trait on a given type, and a function can't. The downside to implementing a macro instead of a function is that macro definitions are more complex than function definition, because you're writing Rust code that writes Rust code. Due to this indirection, macro definitions are generally more difficult to read, understand, and maintain than function definitions. Another important difference between macros and function is that you must define macros or bring them into scope before you can call them in a file. As opposed to functions, you can define anywhere and call anywhere. Okay, so bringing them in front of me could be a challenge. Declarative macros with macro rules for general metaprogramming. Okay, so the declarative macro is the most frequently used. They're also sometimes referred to macros by example. Macro rules macros, or just plain macros. What? At their core, declarative macros allow you to write something similar to a Rust match function. Match functions are control structures that take an expression, compile the resulting value of the expression to partons, and then return the code associated with matching partons. Macros also compare a value to partons that are associated with particular code. In this situation, the value is the literal source code passed to the macro. The partons are compared with the structure of that source code. And the code associated with each parton, when matched, replace the code passed to the macro. Ugh. I want to see an example. To define a macro, you use macro rules construct. Let's explore how to use macro rules by looking at how the vec macro is defined. Chapter 8 covered how we can use the vec macro to create a new vector with particular values. For example, the following macro creates a new vector containing 3 integers. I'm not teaching Rust, I'm learning Rust, but welcome. I teach myself. I'm trying to teach myself. And grab a bunch of people. To learn or suffer with me. I'm a very dedicated background noises that somehow entertain people with my suffering. That it's who I am. So we have a vector of 1, 2, 3, which use the vec macro to make a vector of 2 integers or a vector of 5 string slices. Anyways, that's what vec can do. We wouldn't be able to use a function to do the same because we wouldn't know the number of types or types of value up front. So that's why we are using a macro. I'm not there to teach the creator of Rust. Oh my gosh. Oh my gosh. I know too little. What is the background music? It's a nice BGM. Oh, accidentally closed it. It's called Watayuki no Kyoku. It's like the memory of snow. I plan to switch to a different one after I'm done with the Rust stream. Okay, so now we are looking at the definition of vec. Oh, okay. This is pretty much simplified. Oh my god, my cat. Hello. Don't drop the microphone. Come on. Sit on me. Okay, I grabbed the cat. He's happy. I'm happy. Hungry cat is back. He's not hungry. He's just needy. Yeah, a needy cat. Oh. What? Anyways, they are not the same definition. Let's look at the simplified definition. So we first initialize this big chunk of vec, and we push the element in it. Wait, what? This is generating Rust source code, is it? I'll just put this code here so we can all see it. So this annotation indicates that this macro should be made available whenever the crate in which the macro is defined is brought to scope. So basically it's available anywhere. whenever it is brought to scope. We start the macro definition with macro rules, and the name of the macro we are defining without the exclamation mark. So this doesn't have the exclamation mark. And with curly brackets, we define the macro. We have one arm with pattern this, followed by this arrow, and then the block of code associated with the pattern. If the pattern matches, the associated block of code will be emitted. Given that this is the only pattern in this macro, there's only one valid way to match. Any other pattern will result in error. More complex macros will have more than one arm. Valid pattern syntax in macro definitions is different than the pattern syntax covered before, because macro patterns are matched against Rust code structure rather than the values. So a set of parentheses encompasses the whole pattern. That's the set of parentheses. And a dollar sign followed by set of parentheses that captures values that match the pattern within the parentheses for use in the replacement mode. And within this is this, which matches any Rust expression and gives the expression the name X. The comma following this, the comma, indicates that a literal comma-separated character could potentially appear after the code that matches the code. And this star specifies that the pattern matches 0 or more of whatever precedes this. So, in vector we have 1, 2, 3. And the dollar sign X is matched to 1, 2, 3. And the comma is also kind of matched. So we initialize a new vector and then we push each element into this temporary vector. And finally, the temporary vector is returned. There are some strange edge cases with macro rules. In the future, Rust will have a second kind of declarative macro that will work in a similar fashion but fix some of the edge cases. After that update, macro rules will be effectively deprecated. With this in mind, as well as the fact that most Rust programmers will use macros more than write macros, we won't discuss macro rules any further. Okay, so this is gonna be replaced someday. So that is the current declarative macro. And my cat is already asleep, and I assume some of you are too. So wait, are we still using macro rules now, or is this pretty old? Hello, Paul. Welcome. Still macros. Okay, let's wait for the new version to come. And after the declarative macros, let's move on to procedural macros. Procedural macros, which act more like functions. Procedural macros accept some code as an input, operate on the code, and produce some code as an output rather than matching against patterns and replacing the code with other code as declarative macros do. Who could sleep with shocking plot twist like hungry cat go to sleep? Oh, he's sleeping on the table. Not on my lap anymore. First time in Europe, probably should start from beginning of the series. Welcome, Sleepy Desu. Welcome. You don't need to start from the beginning of the series. Just read the book. You'll be fine. You'll be fine. Welcome. You can join the Discord group to meet more cute people. Welcome, Black Sun. You're finally out of work. Congrats. Congrats. Take a break. Okay. Procedural macros. Procedural macros, there's 3 kinds. Custom derive, attribute-like, and function-like. When creating procedural macros, the definitions must reside in their own crate with special crate type. This is for complex technical reasons that we hope to eliminate in the future. Using procedural macros looks like the code here, where some attribute is a placeholder for specific macro. So for using a specific macro, okay, let me look at this. The function that defines a procedural macro takes a token string. It takes a token string and produce a token string as an output. The token stream type is defined by proc macro crate that is included with Rust and represent a sequence of tokens. This is the core of the macro. The source code that the macro is operating on makes up the input token stream, and the code that the macro produces is the output token stream. The function also has an attribute attached to it that specifies which kind of procedural macro we're creating. We can have multiple kinds of procedural macros in the same crate. Okay, let's look at different kinds of procedural macros. Okay, so how to write a custom derived macro. So we can create a crate named hello macro that defines a trait named hello macro with one associated function named hello macro. That's a lot of hello. Rather than making our crate user implement the hello macro trait for each of the types, we'll provide a procedural macro so the user can annotate with their type with derived hello macro. This is complicated. This is complicated. How do I create a crate? I'm sort of forgetting. Is it just Rust new? Rust new? What? What? Why am I saying Rust? I'm so rusty. That's bad. Cargo new. Dash library hello macro. Oh dang it, I created inside the chapter. I guess that's okay, although not perfect. Okay. Here we are. Rather than making our crate user implement the hello macro trait for each of the types, we'll provide a procedural macro so user can annotate their type with derived hello macro to get a default implementation of hello macro function. The default implementation will print hello macro my name is type name, where type name is the name of the type on which the trait has been defined. In other words, we'll write crate that enables another programmer to write code using our crate. So when people use this derived hello macro, it's going to print hello macro my name is pancakes. Pancakes. When we're done, the first step is to make a... Oh, it talks about it here. So... in the library, we have a public trait hello macro as a function hello macro. At this point, our crate user could implement the trait to achieve the desired functionality. I'm confused. Do I create another main function here? A main file? And have these babies? Or am I supposed to create a new project? Let me do some research. I feel like something is missing. Anyways, I'll just follow this and see where it brings me. We have this, we have a trait and its function. Our create user could implement the trait to achieve the desired functionality. They will need to write an implementation block for each type they wanted to use with hello macro. They want to spare them from having to do this. So here you want to print the name of the struct. And Rust can't look up the type name in the at the runtime. So we need a macro to generate code at compile time to be able to print the type's name. So we need to define the procedural macro. For crate named foo, a custom derived procedural macro crate is called foo derived. So inside our hello macro project, oh, it seems to be alive. And let's create a derived. Toggle new hello macro derive library. So we have a library. We could instead have the hello macro crate use the hello macro derive as a dependency and re-export the procedural macro code. We need to declare this derive crate as a procedural macro crate. We also need a functionality from the scene and code crate, as you'll see in a moment, so we need to add them as dependencies. Add the following to the cargo file for hello macro derive. So let's see the explorer, and we have a hello macro, and in the cargo file we're going to write some scene and quote for the dependencies. And library book procedural macro equals to true. To start defining the procedural macro, place the code in where? In here for the library file of the hello macro derive crate. So extern crate rogue macro procedural macro. Let me delete this big boy. Procedural macro token string. Use quote. Use sync. Book macro derive hello macro. Public function hello macro derive. Input token string. And output is also token string. Construct a representation of Rust code that we can manipulate. Oh. Implement hello macro. Build a trait implementation. What the heck is this? We have this big boy in the derive. We split the code into the hello macro derive function, which is responsible for parsing the token stream. It parsed the token stream and implement hello macro function, which is responsible for transforming the syntax tree. This makes writing a procedural macro more convenient. The code in the outer function, hello macro derive in this case, will be the same for almost every procedural macro crate you'll see or create. The code you specify in the body of inner function will be different depending on your procedural macro's purpose. We have introduced 3 new crates. procedural macro, scene, and quote. The procedural macro comes with Rust, so we don't need to add them to the dependency, but the rest of them needs to go to the cargo.tomo. The scene parses Rust code from a string to data structure that we can perform operation on, and the quote turns scene data structure back into Rust code. This make it much simpler to parse any sort of Rust code we might want to handle. Oh, so those are the stuff that parse the Rust source code. The scene parse the source code into a data structure. And the quote parse the data structure back into Rust code. Where did we use the quote? The hello macro derived function will be called when a user of a library specify this on the type. This is possible because we've annotated the hello macro derived function here with procedural macro derived and specify the name hello macro, which matches our trait name. This is the convention most procedural macros follow. The hello macro derived function first converts the input from a token stream to a data structure that we can then interpret and perform operation on. It takes an input and converts to a data structure. I feel like the AST is like some sort of tree. Abstract syntax tree. It already turned the Rust code into a data structure. The parse function in scene takes a token stream and returns a derived input struct representing the parse Rust code. Oh my god. This is a pancake. A pancake has been flattened. Has become a tree. I am so confused. I'm not confused, but confused. So we turn Rust code into a tree. It shows that the code we have parsed is a unit struct with an identifier. And we'll be using this to let Rust write some Rust. This is like teaching my grandbaby to walk. The output of our derived macro is also a token stream. The return token stream is added to the code that our crates user writes, so when they compile their crate, they'll get extra functionality that we provide in the modified token stream. Heck, nickel granny. I don't want to be a granny. But this code is asking me to be a granny. Or make my baby a parent. Well, I'm the granny. You might have noticed that we're calling unwrap to cause the function to panic if the call to parse function fails. It's necessary for our procedural macro to panic on errors because the procedural macro derived function must return token stream rather than result to conform to the procedural macro API. We've simplified this example by using unwrap. In procedural code, you should provide more specific error message about what went wrong by panic or expect. Now that we have the code to turn the annotated Rust code from a token stream into derived input instance, let's generate the code that implements the hello macro tree on the annotated type. Finally, our baby is producing more baby. Pancakes! Pancakes. Our pancake babies, let's go. So we're taking a abstract syntax tree and we're generating code from it. We take its identifier and what? Is this a generator? Oh, the code is here. What does code do? Where did my Rust analysis go? My Rust analyzer. It decided not to work because it's too complex. Or I'm having some sort of bug. Anyways. Oh my god. A code. I think what the code is doing is converting the abstract syntax tree back into code. So we're implementing hello macro for name. And here we have a function hello macro. And we print the type. We went all this far to trying to print a pancake. Hello macro, my name is pancake. Which also could be orange cake. If the name is orange cake, it can be anything. That's why it is code writing code. Code is a macro to write Rust code to convert to AST. It takes AST and convert to code, right? Okay, that's the Jane. What are you? And I don't know what Jane is into, but it's into. Okay, let's look at the explanation. We get an indent struct containing the name of the annotated type. When we run this function, did I say indent? It is identifier. The identifier struct contains the name of annotated type, and the identifier we get will have the identifier field with value pancakes. And we return the code, the Rust code we want to return. The compiler expects something different to the direct result of the code macros execution, so we need to convert it into a token stream We use the into function, making into a token string. The quote macro also provides some very cool templating mechanics. We can enter name and code. We'll replace it with the value in the variable name. We enter name and code will replace it with the value in the variable name. We want our procedural macro to generate an implementation for our hello macro trait for type user annotated, which we can get by using name. The trait implementation has one function, hello macro, whose body contains the functionality we want to provide. Okay. And we turn this name into a string. So pancake will be a string that has pancake. So you write almost real code inside code macro. The macro gives you its AST, then you give it back to compiler. This is my almost real code. The macro give me AST and I gave it back to compiler. Oh my god. This is like trading with 5 different people. I'm completely confused. Oh my god. So if I cargo build, where do I have capitalized stuff? Wait. This is over here. This is capitalized for a reason. Or no. Or yes? Anyways, somehow it's capitalized. Hello macro derived, cargo build. Taking so long to build it. Joe, welcome. Hello. Arrows. I think my Rust analyzer just decides to die. Did it? Yeah, it decides to die. Let me try to restart it. Just compiler. It's too buggy. How do I restart the Rust analyzer? Anyways, I'll look at the Alias. Hello, macro Derived. What is wrong with you, baby? Is it not returning what it wants? Expected struct procedural macro token stream. Found. Is this not token stream? Cannot infer type for type parameter u. Oh, Russ analyze the dice when macros fail? Oh my. That is sad. So I'm on my own. No more Russ analyzer. Oh, right. Okay, this is the part I'm missing. I didn't specify the return type. Thank you. And what else? It is a token stream. Expected struct. Did I not save? Oh. I'm returning that. Okay. It worked. Nice. It worked. So create a new binary project in my project directory called pancakes. Now go into the pancakes. Da, 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 da. Add those into my dependencies. Hopefully it's like this. My Rust analyzer is alive. Hello, Dragos. Welcome. Welcome, Zao. Hello. Long time no see. How are you? Oi. And let's call the pancakes. Haha, what's going on? Wait, this is not the... Is this the one? Yeah, this should be the one. Wait. Oh, the split screen. The split screen. On my desktop is also the same setup. One side is the web page, the other side is the code. How's progress? Almost done. I'm hoping it's almost done. Hello Macro is not a member of Trade Hello Macro, not a member of Trade Hello Macro. Expected function from the macros stringify. Looks like it is sort of able to find those. But when the pancake calls the hello macro, let me look at the entire error message. actually a function. Oh. The exclamation mark. Thank you, Dragon. I think you caught it. And... did I save? Was it a save issue? Okay, it wasn't. Ooh. My head exploding. Function or associated item not found in pancakes. Why are there stars in my eyes? I'm not too excited about it. Stack overflow. No. Oh, you mean stack overflow as a forum. By renaming, but it was just a warning. cannot find the hello macro. I saw this. I thought this is going to find this. I stuck in an arrow, but that's okay. That's okay. Don't worry. This is what we do all day. I feel like I must be missing something really small. I was caught or not. I realized the ROS analyzer will have a tiny warning sign. When there's something wrong. A cat scan you for mouse. I think cats are smarter. They're better than me in finding moving stuff. I find bad insects like every week because my cat likes to play with them. Ask my sleeping cat for help. I don't know where he went. Oh, he's enjoying a sunbath. He despises He doesn't like an owner that can't find a bug. Oh, he actually meowed. Oh, he's here now. Trying to offer me help, are you? Hello. The mouse smells bad. What package am I on? Hello macro. Hello macro derived. Okay. Oh. You guys have been keep telling me about this. And I just ignore it. I feel horrible. Oh. Looks like that is it. I should have listened. Ah, I should have listened. Thank you, Dragon. It is the lowercase hello. Oh. This goes here. And it worked. The pancake is finally out. The pancake is finally out. Wee. I'm not smart. The chat is smart. I've been implementing hello with trait when the trait definition says hello. The trait definition should say the small h. That was low. But we get it. Nice. Okay, moving on. Attribute-like macros. What is attribute-like macros? They're similar to custom derived macros, but instead of generating code for a derived attribute, they allow you to create new attributes. They are also more flexible. Wait, what? They're similar to custom derived macro, but instead of generating code for a derived attribute, they allow you to create new attribute. The derive only works for structs and enum. Attributes can apply to other items as well, such as functions. And here's an example of using attribute-like macro. Say you have an attribute named route that annotates your function when using a web application framework. So we have a attribute route. The route attribute would be defined by the framework as a procedural macro. The signature of the macro definition will look like this. So we have a route. We have two parameters of the type token string. The first is for contents of the attribute. The second is the body of the item in the attribute. Let's go back to the folder. My temporary scratch pad. Thank you for subscribing, Dr. Carl Green. Welcome. Oh, this is just a closed segment. Where's the function index? It's all here. Attribute-like macros work the same way as custom derived macros. You create a crate with the procedural macro crate type and implement a function that generates the code you want. So it's also about code generation. And this feels like quite common in building a web application. Okay, that is attribute-like macros. And lastly, we have function-like macros. Function-like macros define macros that look like function calls. Similar to macro rules macros, they are more flexible than functions. For example, they can take an unknown number of arguments. However, macro rules macros can be defined only using the match-like syntax we discussed in the section before. Function-like macros take a token stream parameter, and their definition manipulates that token stream using the Rust code as the other two types of procedural macros do. An example of function-like macro is SQL macro that might be called like so. So what? That's how you do SQL in Rust? This macro would parse the SQL statement inside it and check it's syntactically correct, which is much more complex processing than a macro rules. The SQL macro will be defined like this. This definition is similar to the custom derived macro signature. We receive the tokens that are inside the parentheses and return the code we want to generate. Okay, so SQL is a function like macros. Okay, we reached the end of the chapter. Summary. We learned some Rust features in our toolbox that we won't use often, but we'll know if they're available in very particular circumstances. We've introduced several complex topics so that when you encounter them in error message suggestions or in other people's code, you'll be able to recognize this concept and syntax. Use this chapter as a reference to guide you to solutions. Okay, that is the advanced features of Rust. It's been a wild ride. And on Saturday afternoon, for the North America people, we will be doing the final project, building a multi-threaded web server. Thank you, Dragon. Thank you guys for helping. I don't know if you guys weren't here. I would never finish this book. This is like the first programming book I have read. Like, I have actually read aloud. And my cat is so happy he started to throw my water underneath the table. Web server sounds like a pain. I feel like it's gonna be fun. I like chunks of code that works together. Alright, I'm going to feed my hungry cat and hope you guys have a awesome week. We'll be continuing learning on Saturday. I'll see you next time. Bye bye. Oh my god, stop pushing the microphone. Bye bye Tule, bye Adam, bye Hafnia, bye Bajar, bye Kejo, bye Adam, bye Batomi, bye Maxim, bye Mix, bye Putonen, bye Roboto, bye Inspector, bye Black Sun, bye Nerdy for Afro.